So, hello guys, and welcome to this video. Today we are here to present but a panorama generator in Minecraft. I know this has been done before. In fact, I had the inspiration for this video by when I heard that Redstone Jazz actually made one in Minecraft. I haven't really watched this because I was really more about the concept. For me, I was like, that's actually interesting. Because for some time I have been working on another project in CBP, which is the Command Block Parser, which is a program made by Wubbi. It will remind you of the Redstone programming language by Tosha, in case you know that. It basically allows you to write programs with command blocks in a quicker way, but it's still a real compiler because, well, in my opinion, it does do some cool stuff. Like you can say trigger this structure, and then you don't have to fill in any coordinates. It just will fill those coordinates in later on, and so fill clocks and that kind of stuff become really easy. But yeah, for most of the commands, they are still the same, and I know there are some optimization, some easier ways I could have written my code, but I do not know all of the macros which are inside of the system, basically. So as a result, I didn't really. I just went ahead, read a bit about it, but also didn't go for the most efficient method always. The programs, which of course are outputted, should be pretty efficient, regardless of how I wrote them in CBP. So, with that being said, of course, thank a lot to Wubbi for the program, but he basically, so the backstory behind that is that he demonstrated it for the first time on a stream, I think, like half a month ago or something, or maybe 3 weeks or something, 3 weeks. And yeah, there a couple of people watching, including me, but it looks like I was the only person who was really interested in it, so, well, no offense to the others, but most people were just there to talk for a bit, which I also do a lot on streams, so there's no problem with that, but I just was like, this is actually cool stuff. So yeah, and then Wubbi apparently wanted to hear about some tests and stuff, see some other people use it, and from that day I thought about making another project, yeah, I'm gonna go ahead and say it. It will be a 4-bit polynomial plotter, but that would be quite complex, and I've worked a bit on it back then, but I wasn't really motivated. I dropped the project, wasn't really motivated anymore because it turned out to be a lot bigger than I expected, even for such a simple program, because it's Minecraft. But then I heard about this and I was like, well, this is a small project. We can do this in several hours and it should be done. And yeah, then Wubbi also has another test, and yeah, so that's the whole backstory behind this thing. I know it's getting lengthy, but if you're watching this, you probably are just interested in, well, command blocks in general, so you can withstand the long story. Anyway, let's showcase this baby. So I have a lot of different versions of the program, as you can see. Every version consists of a tower and 2 of these start and stop block structures, or groups, or whatever you want to call them. The quickest one in the beginning, I would say, is like the 9th one, well, the 10th one maybe, but let's just go for starts. And I'm an idiot. Yeah, apparently I addressed them the wrong way, so I just changed that. But as you can see, it's getting primes really quickly. It's already at the first prime above the 1000, which is about the 200th prime. It also counts which prime it is, which is pretty cool. So yeah, this one, however, will get quite slow after a while, because basically what it's doing, for every prime it generates, it is generating also an entity to store a couple of a bit of data in, and yeah, this will slow down your tick speed quite severely. I can show you that here. This is a clock. Just 1 tick repeaters. Normally a cycle in here should take 10 seconds, but let's just count. Okay, let's try again. That looked like something like 6 ticks slower than normal, 6 times slower than normal. So yeah, oh well, actually let's keep it on. Once it is back over here. Yeah, I can really slow. Yeah, doesn't make sense because they are almost 500 armor cents already, and but luckily they're invisible because so my graphics card doesn't have to render them. Now it's also getting slower on my FPS because I actually have to render them. But before, without, if you just keep them invisible, it's only going down your tick speed, and you won't notice a thing. Just walking around, it's about like breaking blocks will get slower. If you would be on a server, I suppose. But yeah, so that's one demonstration. I'll just stop it, passing that up here. Now, of course, download for this whole thing will be down below in the description, maybe with signs which say the right stuff. So yeah, I think I'll also explain the backstory behind it. Make sure to check out CBP; it's pretty interesting, and allow you for to write some Minecraft stuff a bit easier, I would say, especially bigger project, I suppose. And also like stuff like what the advanced stacker did. Of course, all of it can be done with CBP as well. In case you know the advanced stacker, that was a pretty useful filter in my opinion. But yeah, this allows you to do all of that and way more, of course. Now let's get into what this is actually doing. How does the algorithm work? What's the difference between all those different structures I generated here? Because I could show you a smaller one, for example, like the 5th one on the back row. It should be this one. This one is pretty optimal to go for a longer distance, I would say. So yeah, it will take a bit longer to get to like 1,000, maybe 2,000 as well. But from actually no, this is the quickest one to get to 2,000 of all these. That's the result from one test I did. All the tests I did actually one test on every one of these, and I wrote down when they hit 1,000, 2,000, and 3,000. So yeah, you can also get those test results in the description, along with the source code, you could say, for the program. There are two settings which you can edit in constants.cbp, and then you can use CBP to parse all that, and it should work. Make sure to read some of the commentary though. If it's not working, you have to get some red imports going and such. So yeah, as you can see, it took a little bit longer to reach 1,000, but now compared to that one, it should be picking up, catching up. So yeah, that's pretty good. Now let's just stop it. I think actually now it's time to get into the mechanics behind these things. So a very basic over here we've got the most basic machine. This has no optimization I will discuss later on, and it also has no. It also is just at speed 1, as I call it. Now, so let's just get over it, right? Over here we've got well, you've got a summon. How should I say this? Okay, actually I'm gonna look at my code. I think that will be a bit easier to explain. Then again, I can't look that much at Minecraft anymore if I do that. So, alright, I think I've got it on right now. So basically, if you click this, first of all, it will replace whatever is above with redstone block, and then it will turn itself off again. So you just trigger this command block, and that will trigger the whole thing. Then it will summon a controller entity, and that's an armor stand, of course, at this position. And I think that's basically which does all of the global stuff, like all of the calculations which only have to be done once. All of the global variables, they're all saved in this and in this controller armor stand. It's called PNG controller, PNG pad number generator. If I write these programs, I try to name all of them with a suffix, with a unique suffix to make sure that no variables and no names overlap, of course. So over here, we're adding some objectives. So we're adding the objective display normally. Yeah, so display is basically what you see on the right, and we have that's one scoreboard with two entities with a value there. Although these entities are purely fictional, of course. They are you can just say I'll get to it in a second, I guess, how that works. But so that's one display. Then, and also sets the display for them later on, I suppose. Yeah, that's it later on. Anyway, So we've got display, we've got a value, we've got a value prime, which will be used in the controller to determine whether it's prime or not. If it's 0, that means that it is not prime. If it's 1 by the end of the calculation, it's the number it's testing as prime. And what is this number? Well, this number should be test value. That's basically the value we're testing. It starts at 2, it will go up from there. And I also have PNG value. This is used by the individual prime armor stands, which to save the prime they're holding. And they will also use test value as a basically a register which they can use to perform calculations on. Then over here we're just setting the standard scores for the two imaginary entities which store the newest and the amount of primes which have been generated. Then over here we set the display for the display objective. And I think that's about it for this section. Oh yeah, of course we also start with test value at 2. And then it goes over here and it sets this one to a redstone block. And basically this will keep on powering itself. It's just a redstone clock, so first it will remove itself and then it will replace itself, but it uses execute at the name PNG controller. So once we remove the PNG controller, this clock will stop, and that's on purpose, so we can easily also turn the mechanism off, which is quite useful. Then over here we have got, now it's getting a bit more complicated, so you have to look at the order of operations. So first thing we do, we set PNG controller.prime to 1 or true. So we say it's true for now. Then we write the test value, which is currently in the PNG controller. So the value we're trying to test, is this a prime or is this not prime? Then we'd write all that to the test values objective of every prime PNG prime armor stand. So all of the primes which have been generated, all of these objects, you could call them actually, like in programming, they will get this value assigned to that test value variable. Then they take this value, and we will go up here, I think. Now let me just get this straight. I think I may have forgot something. Yeah, wait a second. So, okay. PNG value. Yeah, okay, wait a second. I got a bit distracted right there. Okay, so we set all those test values to, well, value we already discussed. Then it goes over here. Then it does the modulo operation. So basically what it will do is it says in programming this would be test value modulo, like that, value. So basically it divides test value by value and it stores the remainder of that operation in test value again. Now this may sound very complicated, but basically what it does is if test value is divisible by value, then we know it's not prime and it will become, the test value will become 0. If it's not divisible, it will become any other value. So that's all you need to know there. And then if if there's an entity, so basically for all entities which have this score set to 0, in other words, all of these primes which can divide the test value into an integer basically. So if the test value is divisible by a prime, then there will be at least one prime entity which will write to the controller.prime variable and set that to 0. So basically, recap, what we do, we store the test value we have into all of those different entities. We divide them, and if the remainder in any of them is 0, in other words, if it is divisible by any prime number we already generated, then it's going to set the prime variable in the controller to 0. And that's what you're going to use from now on to test if the number is prime or not. Because now, if it's 1, it is prime. If it's 0, it's not prime. So basically, in here, what do we have? Yeah, so all of the so if the PNG controller has score prime equal to 1 or higher, then it will generate. Wait, I think that's all over here already. Let me just go check for a second. Yeah, so over here, if that's true, then it will summon another prime, of course, a prime, and then it will set that. It will set its test value to, I think, just a maximum. Oh no, wait! It will set the PNG. It will set the value of the prime to the test value we were currently using. So in other words, that's just setting it to the right value. And then what else do we do? We say that the display value will be the newest value, so we use the test value again, and we will have the amount will be added, will be incremented by 1, and we will also have you also by the end of this whole thing. So first we do this, which will basically set test value to the highest possible value if possible, until it's assigned a new one. So we make sure that there's nothing going wrong there. And by the time that ends, we don't need this special name anymore, which we used to have for basically the new prime we generated had until now the name PNG new prime, and now we just set it to PNG prime like the others. This is just to distinguish between the new one, so we can perform some operations on that, and once we're done, we set it to PNG prime. And at the end here, what it just does is it increments the test value by 1. So the next time it runs this thing, it will be 1 higher. Alright, I know that was a very complicated thing, but I can't go over it again, it's getting too long. So if you didn't understand that, which would be fairly understandable because I'm not great at explaining stuff, and it's also, it's not actually that complex, but it's a bit hard to explain just like that using a couple of command blocks. So if you want to know more about it, just check the source code, but I have to continue. So that's the basic algorithm, and if we want to end it, well, pretty simple. This just fills this whole thing with redstone blocks. This just removes the redstone blocks again. Then this kills the controller entity. This kills all of the primes we had. Then this will what will this do? This will remove all of the objectives we used. So value, test value, prime, display, and amount. And then after that, it's done, basically. So yeah, that is our entire thing. So that's actually a pretty simple algorithms. Now, probably a lot of you are only thinking, well, about this is a slow way to do it, and it is slow. Just look at this, how slow this thing is going. It takes like multiple seconds to go up to 100. Well, you saw over there it only took like half a second to go up to 100. Now, the first and easiest way to make this faster, of course, is to not wait every time for another tick to happen, and which will basically set this whole thing to redstone block again, remove it again. Because this thing will probably already be running at 20 times a second, and then it's basically limited by the tick speed. Now, to get across that, you can just take all these command blocks, except for like the 2 bottom ones, which reset the thing, and you can just copy them over. Because they will be performed in one specific order, you can just perform all of that multiple times within a single tick, and it will say in the right order of execution, which is pretty cool. So that's basically what I did. So I wrote a setting which will loop through a couple of these command blocks and add them, and that's basically why this tower is getting bigger, but it's also getting faster because it is not limited as much by the tick speed. It can do 3 times as much operations within tick speeds. So basically what this means in practice is that it will be able to calculate higher value, low values more quickly. But so the higher this tower is, the better it is for short range primes, basically. Once it gets longer, then the calculations are going to take very long anyway to do, it seems, so it doesn't really matter much. And it's starting to take more time to reset the whole pillar, it seems. I don't even know why, but that's what our test results indicate. So let's just show As you can see, prime numbers are getting way quicker over here, but it will actually slow down quicker normally as well. So yeah, that is that optimization, you could say, but it's not even optimization, it's just a very basic way to increase the speed. That's also what we did over here, but over here we are also using another optimization, which probably a lot of you already thought about, which is, well, we are already doing something which is kind of mathematical. We are only checking if there are any primes below our number. We're checking which can divide our number, yeah, wholly, basically. Some of you may think, well, why are you not checking over all numbers? Maybe we're checking 15. That means that we would be that having primes 2, 3, 5, 7, 11. And like, I know 15, you can say like, I know 15 is actually not divisible by any other number as well, but say it would be divisible like something like 8. Then you have a problem. And then, but the thing here is that that's not gonna happen. Because prime number theorem says, I'm not sure what it's called, but it's like a big thing in mathematics, that there's one way to divide this into prime factors. In this case, it will be 3 times 5. In other words, there will be prime numbers, which will be able to divide any number as long as it's not prime itself. Other prime numbers, of course. And of course, because we're multiplying, that means that we're multiplying integers, so integers larger than 1, primes to be precise. So that means that whatever factors are on the right, they have to be smaller, both smaller actually, than what's on the left. So there's no way you can do, for example, it could be, for example, 23 times 3. Because if you have 23, then there's no integer you could take, let alone prime, to get to 15. You would have to use a rational number, smaller than 1. Anyway, so with that out of the way, you may have to think like, but then why are you even checking for all primes? Because, for example, if you're at 15, then if you know it's not divisible by 3, so not divisible by 3, well, actually you know that, so yeah, we'll check using the wrong example here. Basically, this will work perfectly fine because yeah, basically it will hit 3 and it will be, so it goes to 2, it goes to 3, and then it's like, oh, it doesn't work, alright, let's stop. In Minecraft you can't really do that because I'm going to have to use a loop and you have to use actually, maybe you could do an optimization for that, but I'm probably not gonna do it. It would be a bit more complex, but maybe you can do it, that it cuts the loop in, basically right away, as it is, if it has found a number which divides the test value. But say we use an actual prime like 31, we know that 31 is in between, well, actually no, let's not say that already, but we, for example, check if it's divisible by 3, and we result is that it's not. We say it's divisible by 5, nope. And then we can do that for 7, for 11, but some of you may already have thought of something here, and that is, we don't know if this is prime technically, but if it's not divisible by 3, nor it is divisible by 5, and we know that it has to be written as a number of prime factors. It can be written as itself, maybe, that would mean it's prime, but if it's written as if it's not a prime itself, if it's written by if it's written as a product of multiple primes, that would mean that those primes are in a pretty low range. In fact, if you think about it, if you have a number, a is not prime, so a has has a series of prime factors, so b1, b2, and so on. But the thing is that, as I already said, it means that because our numbers we're multiplying here are integers larger than 1, this means that every time we do a multiplication, the number will get larger. In other words, to stay below that limit, so in order to have it be equal to a and not be way larger than a, the product has to consist of numbers which are actually quite small, you could say. Now the thing is, if you know it's not 2, or 3, or 5, then you know it can also not be some number, let's say C, which would equal to bit hard to put this, but there's probably better explanations for this. But basically, you know it can't be a C, because then C times 2 would be a way to write it, and of course 2 is would be a prime factor, so then this would also work. Of course, it wouldn't work with 31, but I hope you get the gist of it. So let's say some not prime number like 30. So we could, if we find some C that is equal to 2, then we already know that it also works the other way around. Of course, that's just, yeah, mathematics basically. As long as C is of course not 0, but that's an exception, and which not gonna happen in this scenario. Now, thing is though, that because we know that it's basically if it's a prime smaller than the square root of the number, so well, what I'm getting here at is that you only have to check the primes up to the square root of the number. Why? Well, I'm not going to get into mathematical proof because that would take ages, but it has to be a multiplication of primes. Of course, they have, like, if you have something like 30, it can be 2 times 3 times 5, but it's actually a bad example, so let's use something like 26, which is 2 times 13. Now, 13 is way larger than the square root of 26, definitely. However, by the time we get to 13, we will already have checked 2, which is smaller than the square root, and we will have realized that that actually is divisible, and it will already be not a prime anymore. So the thing is, if a number is not prime, then you know that there will be at least one prime factor, which is going to be below the limit of the square root of this number. So basically, if you try to balance this out as much as possible, to make sure that there's not like one really low, which you're surely going to notice, and one really high you won't notice at all, then you could try it for something like, let's say, like a square basically, 49. But then you will notice that, I'm sorry, yeah, 7 in this case, indeed, it actually is not 7, no, 7 is not larger than, I'm sorry, it's not smaller than the square root of 49, so I have to quickly correct myself, and it's about, there will be at least one prime factor which is smaller than or equal to the square root of this number. If that's not the case, then it is prime, so that will be our new condition, and for this we will have to create another objective. But before I get to that, how are we gonna know what the square root of a number is? In Minecraft, there's no operation for square roots right away, because we only use integers. It's quite annoying. So, especially as you're doing it on a computer, there's also a good practice to actually not check if a is smaller than or equal to square root of b, but to just say if a squared, because we know a and b are both positive numbers, we can do this without any mathematical exceptions. If a squared is just smaller than or equal to b, those two conditions are equivalent, so we can just switch that around, and squaring a number is way easier. That's just a times a. And also it gives you an integer back, so it also can be saved easily using scoreboard values, so that's way better. Also, the good thing about that is that you don't have to constantly find the square root of a new number. Basically what we can do in our case is just store the squared values. So if we find a prime, we will not just store the prime, we will also store the square of the prime into that prime object. So we can basically check every time we're doing this, prime that squared is smaller than test value. And this of course helps a lot, because we don't have to square anything, we just have to get a memory value, because we already calculated this one time, so this will just be a new variable, basically like prime 2 or something, and we have to check if it's smaller than or equal to our test value. Let's get it straight. Alright. However, just checking if two objectives are smaller or larger than each other, a bit annoying to do. So basically we're going to notice how computers do this on a very fundamental level. I'm going to check if this the square of the prime minus the test value is going to be smaller than or equal to 0. In other words, we will only we only have to check the primes if this condition doesn't apply. So not that n is larger than 0, or in other words, is larger than or equal to 1, because we're using integers. Now this will be our condition. Why? Because it's actually not too hard to calculate. Basically what we're gonna do is we're gonna store the square of the prime into our prime object when it's generated in the first time at summoning. And then every time we increase test value, we basically know that the... Oh, no, wait, no. Let me just get this straight. I actually made a mistake here. What we do is we say that prime 2 is going to equal prime squared minus the test value. Alright? So basically that would mean that... oh, dang it, I'm doing something wrong here now I think about it. Yeah, that was the reason. Actually, what I'm doing is this. And I forgot why, but I'm pretty sure this was what I was doing. Yeah, you know what? I'm just gonna cut this right here. It's already getting pretty long, so I don't want to make it any longer. Just gonna think about it, and I'll be back when I have realized what I'm doing here. Alright, I am back, and I think I know how to explain this. For those who still hang around after half an hour of derpy explaining, kudos to you. Basically what we're doing here is when the prime is first generated, we know that actually the prime is equal to test value. So what I just wrote can also be written like this, basically. So basically what is left is the amount of numbers, which is, you could say, the difference basically between the square of the prime and the test value, which basically means if we have our current prime, we will have to wait until we hit prime squared until we have to use this number. So that actually means that we have a counter, you could say. Actually, I'm using the counter is called in use. So when you first generate this, we say this is prime times prime minus 1. And this basically means that we have the distance. When we should first generate it, this is the distance, we could say, between the prime we just generated and the primes ones we will have to, the test values where we will have to start using this prime to make sure that our result is still right. So what we basically would do here is that after every step we decrease the distance by 1, because test value is incremented by 1 at the end of every step. So as a result, all of for all objects prime, if let's put it, I think something like this: if test value is larger than or equal to 1, then in use will be decremented. That's basically how it's working, the algorithm. So that basically means that every time you increment that test value, the distance of all and saved in all of these primes is also reduced by 1, which makes sense. So to put it as an example, because it was very theoretical and you probably don't fully understand it by now, so a better example would, for example, be we have one prime number, only 2, we hit 3. It checks, is 3 divisible by 2? It says no. We already went over how that worked before. Then it will be alright, create prime objects. So we will say prime, well, no, actually the value will in this object will equal 3. But then we take in use, which will be 3 times 3 minus 1. So in use will be 6. Then we will, the test value will be incremented, so it equals 4. And then in use will be decremented, so it equals 5. Decremented, yes. So basically what we have done is test value 4, in use 5. then it will not check 4. So we're checking for 4. The square root of 4, 2 is smaller than 3 squared, then smaller than 3. So as a result, yeah, we basically don't have to check that. Yeah, that's a good way to put it. So we basically don't have to check if 3 is divisible because we already know mathematically that it can't be. So then we do the next step. We test value 5, and in use in this very prime object will be 4. Same thing, square root of 5 is larger than yeah, it's still larger than, no, it's still smaller than 3, I'm sorry. So as a result, it still won't test for 3, and, well, actually, the reason it doesn't test for 3 is because 4 is still larger than 0. But this is the actual condition we wanted to test. And this is our way we're testing it, and it's a bit easier to do, basically. So 4 is still larger than 0, so that's also alright. So we can continue on this pattern. Test value 6, in use 3. The test value 7, in use 2. Test value 8, in use 1. Then last time, then this will be the last step. Then it will test 9, and it will see that in use is not larger or equal to 1, because it's 0. As a result, it will actually use 3 in the calculations, and as it turns out, 9 is actually divisible by 3, so not prime, and it will continue. So then next step will be 10, 0, because in use is smaller, because in use is not larger or equal to 1, it's not decremented anymore. Doesn't matter that much, but it saves you some calculations, of course. And yeah, it will just continue, and it will, from now on, it will use this prime number 3 for all of its calculations, which is good because, for example, here at 15, it will need it again because 15 is divided by 3, so not prime. Yeah. And because we are using 3 now, we don't have to use 5 in this example because the 5 value is still quite far away. This is still 10 there, so 5 dot in use, you could say, is still equal to 10. So it's good that we have 3 now at 0 because we need it. That's the only prime it's gonna check, but that's also the prime which is gonna work out. This all worked out mathematically. So yeah, that's pretty cool in my opinion. And I think that is this optimization explained. I'm not gonna go into the command blocks, but that's pretty much what it does. I think I went down enough to machine level, you could say, so you can see how you can do this with scoreboard values and armor stands. And yeah, just for the rest, what we did is just the same thing. To increase the speed, we increased the amount of executions per tick. And yeah, I can have some test results of that as well. Let me just quickly grab those on the sides. Alright, now to reach 1000, which is pretty low actually, the best would be 9. This is the 9 times, that's 10 times the speed. So as you can see, this is going pretty damn quickly, but it will also start slowing down a lot afterwards, as I already said. Yeah. Also, something I have to mention, with the optimizations, this is technically a bit more long range than the short range, without the optimization, but really, it saves you very little time short range, so I would use the optimization in almost all cases. But yeah, as you can tell, reaching 2000, but it's already getting a bit sloppy, a bit slow. So yeah, let's show you. For 2000, the fifth one is better. That was my optimal one during tests. You can just check the test results in the description. Again, they're just measurements, they're not objective numbers, so you can do your own test. I will include a schematic in the description. You can do analysis on my test results or whatever. I don't know. So yeah, this is going a bit slower, 2000, as you can tell. In fact, it should take something like 10 seconds instead of 8 to reach 1000. At least it did in my test. Because I'm recording right now, it will be definitely a bit slower. Also, you can maybe dedicate more CPU to it or something, but yeah, it really depends on your machine. Anyway, All these numbers you can find in the description. They are, of course, relative to the conditions I was using during my tests. I did, however, try to keep them constant. So yeah, now we hit 2,000, so that's how quickly that goes. And in order to reach 3,000, it takes almost a minute, but the best one seems to be speed 5 again, actually. That's pretty strange, but alright. I shouldn't have stopped it. I'm an idiot. Oh, sorry. So yeah, that would take a minute or something, so I'm not gonna show that actually, because it's already getting pretty long. It will be a 40-minute video or something, maybe 45. Anyway, yeah, I think that's gonna be about it, guys. I think is pretty cool, but yeah, of course, no survival use whatsoever, or creative use really. Even though it uses command blocks, but yeah, I just thought it was cool to make with using CBP. Got some experience with the language. Maybe I'll use it more in the future. Maybe I'll actually finish that plotter someday. Probably not, so don't count on it. But yeah, I hope you found this mathematical explanation a bit interesting as well. I also probably didn't watch till the end of the video. Yeah, that's gonna be about it. So, thanks for watching, and I hope I will see you in another video.